One of these does not work, so I'm just gonna give me a second while I check my configuration. One of these does not work, so I'm just gonna give me a second while I check my configuration. One of these does not work, so I'm just gonna give me a second while I check my configuration. One of these does not work, so I'm just gonna give me a second while I check my configuration. One of these does not work, so I'm just gonna give me a second. Okay, so what we're going to try to do is run ClamAV inside of a Lambda, right? So if you don't know what ClamAV is a like a lightweight antivirus or malware scanner, right? It's open source. It's probably managed by Cisco, I guess. They're the ones who maintain this, or one of those companies maintains this. It's managed by a large conglomerate. And it's lightweight, right? It's pretty small. So if you look at the size of this, if you try and download, this is pretty small, right? It's like 200 MB, and 200 MB size means we can run this inside of Lambda. As you know, Lambda has a limitation of maximum of 10 GB of disk size, right? So we can run this. Very useful if you're trying to create some kind of application where people are uploading files and you want to scan those files with this, right? So how will this work, right? So think of it this way, right? So you have a Lambda function. I'm gonna whiteboard this out a bit, right? You have a Lambda function sitting here, right? We're gonna name it, let's say, ClamAV Lambda. The thing is, since we have our own application which is not there, right? So we cannot install something in Lambda in runtime. So we have to pre-package our application, and what that means is we're going to have to end up using a Docker container, right? So what we will do is our Lambda function has to be packaged like a Docker container, right? We're going to use ECR to be able to do that. So the container registry, where's the container registry? Container registry. Yeah, so we're gonna have we're gonna have a Docker container that we're gonna work with or package as a as an image, right? We'll take this image. We're gonna push this to ECR, right? And then from the ECR, it will be called up into the Lambda function, right? So in principle, it's quite simplistic. Once we have done this, how will we invoke the Lambda function, right? So, and what will it scan? In our case, what we'll do is we're going to use an S3 bucket, right? So we're going to have a bucket somewhere that will house some files, right? Let's say this one, right? Going to have an S3 bucket, and we will configure an event bridge rule, right? Such that whenever a new instance is created in the S3 bucket, our event bridge will trigger our Lambda function. Now there are a couple of ways of do that, right? So instead of using it through event bridge, you could simply trigger an S3 notification directly to the Lambda function. The issue there that you're going to run into is um, you're still going to need the IAM permissions and whatnot. But the issue that we're going to run into is bucket policies, right? So because we will configure an event notification, if you've already configured some bucket policies and IAM rules for that earlier, sometimes the way your client would have set it up, or the way your developer would have set it up, or DevOps guy will set it up, it will cause conflicts, right? So it's a cleaner way to look at the event bridge, which then analyzes your CloudTrail, logs, and then once an event has been created of a, let's say, file being uploaded or file object create event, you trigger a invocation to the Lambda function. Right? So that's what we're going to do. We're going to invoke our Lambda function. This is one way, right? The other is every now and then, let's say I'm uploading a file, right, onto the S3 bucket, but for whatever reason, let's say the scan did not work, right? So you need to be able to give your user the ability to trigger this scan manually, right? In that case, what we're going to do is we're going to have our application basically call this Lambda function directly, right? Again, there are different ways of doing this, right? What we will go do in this particular case is we're going to use an API gateway, right? We're going to use an API gateway. API gateway, and we will create a let's say a path, right, or an endpoint. Let's say scan file, right? We can create a path which will then basically run this, right? So a user can then trigger a scan file notification, or the developer can trigger a scan file endpoint, provide certain data points that we will decide as we develop this. And then once that invocation has been made to the API gateway in turn will call the Lambda function, right? So that is one of the ways of doing this as well, right? And this then solves the problem of, for whatever reason, if the user has not been able to, or the file has not been scanned properly, you can manually invoke the file invocation as well, right? The other problem that we're going to have to solve for this to work is where do we store the definitions, right? Because the binary is fine. Binary we can bundle as part of the Lambda in a Docker container, right? That is straightforward. But what do we do with our definitions, that right, the definition that needs to be updated on a regular basis? You can bundle them inside of the Lambda. There are different ways of doing this, right? You can bundle them inside of the Lambda. The problem is, in that case, you have to rebuild your Docker container image every time the definitions are updated. The other option is you could have the main definitions here and then keep updating them, download it from somewhere else, right? But again, network calls are expensive, so we don't want to be waiting for 2 minutes just for Lambda to download something from the internet. Rather, we need to keep it here. So what you could do in this case is we could keep the definitions in the S3 bucket itself, right? Either the same bucket or a different bucket. Let's say for that matter, we keep it in the same bucket, right? Right. We keep it in the same bucket, let's say. So the definitions then we can pull to the Lambda function during runtime. Now, again, this is a network call. And there are a couple of considerations. So first of all is, if you configure it incorrectly, all of these network calls is going to be over the internet, right? So every time your Lambda function executes, it's going to download some of the updates, right? And the updates are in the range of, it would be about 100 MB or so, right? So every time your Lambda function invokes, you end up downloading 100 MB, um, which is not technically correct, in fact. So what will happen in reality is your Lambda function needs to be warmed, right? So the first time it runs, it will have to download it from the S3 bucket, right? That's 100 MB of traffic. But as long as your Lambda function is warm, is still running, the next invocation will use the same image. And if we can configure our application to not download the S3 bucket every time, right? So if it finds it in its temporary directory, not going to download it, right? So we will configure our Lambda function as such so that we download the definition once. And if I find the definitions on the disk, I'm not going to download it again, right? So it saves me some of the network calls. Again, depending upon the traffic, it could be nothing or it could be a lot. You can solve this problem of traffic going over internet by creating endpoints, but we're going to keep it simplistic, right? The ideal solution is you actually keep the definitions in an EFS drive, right? For that, we have to create the Lambda function inside of a VPC because the EFS drive requires you to have network connectivity within the AWS, right? So we'll probably do that in another iteration at some point, right? At this point, we'll keep it simple, which is our Lambda function will download the definitions from the S3 bucket. Now, let's say we keep the definitions within the bucket, right? How do we update them? Because ClamAV will not allow you to do it manually, right? So it has to be done through what is known as a fresh clam utility. So if you look at ClamAV fresh clam, right? So there's a fresh clam utility which then downloads the signatures, right? The updated signatures. So this has to be done automatically, programmatically, right? So I'm not going to rely on a user or a person to run this manually every month. We're going to automate this, right? How do we do that? We're going to use event bridge, right? So we will create a rule. A cron rule such that, which is part of my event bridge. But we will create a cron rule, which will basically invoke another Lambda function, right? So we're going to have one more Lambda function, let's say here, and we'll call it def, or let's call it signature, right? Signature updates, right? So this will run, let's say, every month, right? I mean, again, every month, right? So we're updating our signatures on a monthly basis, which is generally accepted practice. I mean, you can do it every day also. It doesn't make a lot of difference, right? Because most corporations will batch these and then update them. The only exception to that is sometimes there are clients who will, or could be reasons where you try to deploy emergency, signature update or emergency patch, but those are, I wouldn't say rare, but yeah, rare. So then this signature updates will then download the definitions, download signatures, right? This will pull signatures, but it will also not just pull signature, it will also pull the file, right? Because we're keeping our signature and the file in the same bucket, or yeah, in the same bucket, correct? So we can also have, we also have the file which is getting pulled for a scan. The file will be downloaded on the Lambda function and scanned. This again presents a challenge such that if you think about it, we will run into the Lambda limitations, right? So Lambda has a 10 GB limit, right? So at no point our file can be more than 10 GB. Now, having said that, the file could be 10 GB or less than 10 GB. Let's say it is 5 GB. We still may not be able to scan this because ClamAV runs into problems as the files gets large. Typical recommendation is around 2 GB, maximum of 2 GB. That's why when you use applications such as Google Drive, if you upload a file which is large enough and try to download it, it'll throw an error saying that, oh, I cannot scan this and it will be harmful and blah blah, right? So there's a limitation on the size of the file that we can be scanned using ClamAV properly, right? So this will be our high level architecture, right? Um, of our application. Now, uh, let's see what else do we need? What else do we need here? So we have the Lambda function, we have the signature updates. In fact, you know what? I don't want the API gateway to call my ClamAV Lambda directly, right? I want this to be a standalone utility. So I'm going to create a separate Lambda function, which acts just like a invocation route. Yeah. API Lambda. Let's call it API Lambda. So my API gateway will call this, and then this will invoke ClamAV Lambda function, right? Why I'm doing this is because I don't want to mix APIs and actual, ClamAV utility in the same Lambda function. Totally possible to do that. In fact, totally possible to do all of these three things. It just makes the code a bit complex and unnecessary because you're going to end up using the same resources. The other fact is we will increase the resources here, right? Because we will have files getting downloaded and definitions getting downloaded, files getting scanned, right? So we need more memory. The recommendation, if you look at what's the minimum recommendations from ClamAV, right? What is the minimum specs? Let's see. We're gonna look at configuration, minimum requirements. Why don't we just Google it, right? Minimum requirements. So it says about 3 GB, right? So 3 to 4 GB is where it is at. If you look at the recommendation, right? So it is significant. So we have to increase the default resources of the Lambda function, right? So it comes with, if you recall, 128 GB, 128 MB. We're gonna have to up that to 4 GB of RAM, right? We don't care about the, I mean, it is the task itself requires both RAM and CPU. The scanning is CPU bound, but the CPU is a function of RAM, right? So RAM becomes more important. How much RAM do I need so that I have enough CPU cores? We'll do 4 GB. 4 GB seems to be the limit where it works well, but you could increase it to 10 GB as well, right? So that's the high level function that we will, or application that we will create, right? Now we'll create this in a stream at some other point. I need to go and pick up my kid from the school, but we'll set up our project, right? So I have a very how do I put this? Opinionated way of doing things, right? So what we'll do is we'll set up our project today, and then at some point we will try to create our actual project. So let's try and do that. What I want in this case is a so instead of doing this through Terraform, we will do this through CDK. Now, why CDK and not anything else? I mean, I just have a preference of CDK. That's the whole point, right? Terraform is great. I haven't found it to be great for working with Lambda function. You can use Pulumi, you can use something else. At the end of the day, all the IC tools are almost similar, and I just end up preferring a CDK applications. That's all, right? So we will create a CDK function, right? So I'm not gonna use the default command, right? I'm gonna create it myself. So what we'll do is we'll name the app, and the app will be or the trigger of the app will be npx ts node refer tr external bin app. No, we're not going to pull it in bin. So I like to keep my main entry point as app.ts, right? So we're going to have an app.ts here, and my CDK will trigger this app.ts, right? Just for simplicity's sake, what we will do is we will change the required approval to never. So my app will be deployed by default, right? We don't have to approve it every time. I'm going to set the watch folders as Um, SRC is probably okay, but now we're gonna do it start.ts, right? Because I have app.ts in the root folder. I'm gonna say please look at everything. In fact, I'm just gonna make it start, right? Let's not worry about it. Um, because I also will create, so the actual Lambda function will be created in Python, while the CDK script we will create in TypeScript, right? Again, that's just something which I have learned and works well for me over a period of time, right? Balance of both, properly typed language and flexibility of Lambda, right? We're gonna exclude node modules. We're not gonna watch that. We're not gonna watch the. There's not gonna be a dist folder, but there will be a CDK dot CDK star dot JSON documents, right? So we're going to ignore them. We're also going to ignore some of the JS files that might get created, right? Sometimes we would like to do npm build just to see if the compilation is working properly, right? So in that case we will end up doing that. And then I'm gonna exclude the package files, right? So package star.json. I know I'm wasting a bit of time doing this, but yeah, I do like to do this correctly. All right, so this is done. Next, what do we need? We need to have the context will be configured automatically. I'm just gonna copy my prettier file from somewhere, right? Again, very specific things that I love. You can use your own configuration, don't have to use mine, right? I'm gonna also get my getignore file from somewhere, right? So I have them in my notepad, which I like to use. This is specific for most of my CDK application. I use this, right? I'm also gonna do npm ignore dot npm ignore. We'll just set our project up and let's see where we end up at, right? What else? Let's see. So we need the package, right? So all the packages that we require. Again, I have this ready for a CDK application. I'm just gonna copy this and we'll talk about it a bit, right? So what do we have here, right? So we have AWS. We actually not going to need these, right? So this was another project where I was using the TypeScript application, but we need Lambda. No, we're not going to need this as well. We need CDK is what we need, right? That's the main thing. And then within dependencies, CDK lib constructs, etc. We're not going to nag this project also, right? So we'll just leave it out. And then the API we have already set up as app.ts, right? I also want my rough config so that rough.toml config so that when we work on our Python code, we are able to adhere to the standards, right? Okay, what else do we need, right? So we will need probably nothing, right? So let's set up our main project now. So I'm going to create a SRC folder. Within this, I'm going to create. So we can actually create constructs, right? And so how do we organize this, right? So if you know CDK, we're gonna, or Terraform for that matter, right? So we're gonna have to basically bundle this, right? Now what I want to do is I want to make sure things are sorry, one more thing that we have forgotten, right? One of the reasons why we will do Lambda is we have an API and we need to give an authentication mechanism, right? So this Lambda function should be able to generate a bearer token and validate a bearer token, right? So for that purposes, we could, what we'll do, either we can create another Lambda function or use the same Lambda function, which creates the bearer token. It will keep it in a secret manager, right? Where is our secret manager? There we go, right? So it will keep the secrets in the secret manager and then pull the secret from secret manager to basically validate this, right? And we're going to keep it simple. We'll create a bearer token and we'll use the standard, you know, auth headers to pass the bearer token to API Lambda, and then we will trigger it. Otherwise, the API gateway will be exposed to the internet and anybody could run it and they can basically bankrupt you, right, if they wanted to. So we will do that. We will create a secrets manager here. Secrets manager, right? All right, so this is it, right? So we create our functions within this. Okay, so organization, in terms of organization, what I want to do, I want to split out some of these things, right? So for example, the API gateway, this and the secret manager could be one stack, right? Because they're interrelated, they are, or they could be a construct as well, right? Depends on how we want to do this, right? But let's say we create this as a stack to keep things simple and not worry about constructs, right? And then these becomes a stack of itself, right? So we end up with two stacks. One for the one which is a self-contained ClamAV, ClamAV application, and one which is just for the API essentially, right? Now, the reason why I'm doing it this way is for whatever reason we may not need an API, right? There could be a scenario where there is no need for someone to manually trigger a scan of a file, right? So in those cases, we can just get rid of this and not have to tear down my entire application, right? Just trying to keep a bit of flexibility. That's all. So what we'll do is we'll create the skeleton of two. I mean, we're not going to create it right now, but we're going to create a skeleton of two stacks. So the first one, let's name it ClamAV.ts. So this will be my ClamAV stack. And the second, we will name it as API.ts. This will be my API stack. Yeah. Alrighty. So we have our project set up. We'll come back in some time and try to implement this again.